Today we're going to talk about the discriminant, which is a specific piece of the quadratic formula. The discriminant is b squared minus 4ac, which is the part of the quadratic formula underneath the radical. So the quadratic formula, x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So b squared minus 4ac is the part under the square root. If we have the square root of a positive number, the quadratic formula has a plus or minus in front of the square root. If it's a positive number, you can find both the positive square root and the negative square root. So this first line says, if b squared minus 4ac, the discriminant, is greater than 0, that means it's positive. If the discriminant is positive, then the equation has two real solutions. We are adding the square root and subtracting the square root. That results in two real solutions. If the discriminant is 0, we would have the square root of 0. So in the quadratic formula, you'd have plus or minus the square root of 0. What is the square root of 0? So it'd be plus or minus 0. Whether we add 0 or subtract 0, it's not going to change what the answer is. So if your discriminant equals 0, then your quadratic formula is going to have one real solution. If the discriminant is negative, we would have plus or minus the square root of a negative number. So because of the plus minus, we still have two solutions, but because it's the square root of a negative number, our solutions would be imaginary. So two imaginary solutions when our discriminant is negative. We care about the discriminant because this can help us to match up equations to graphs really easily without having to do a lot of math. So a quadratic equation with two real solutions could look something like this parabola. Notice that it crosses the x-axis in two places. Those are your two x-intercepts, also known as the solutions. So if your discriminant is positive, the parabola will cross the x-axis in two places. If the discriminant is 0, your parabola will touch the x-axis in one spot. So the vertex of the parabola will be on the x-axis, one real solution. If the discriminant is negative, that would be something like this. Notice that that third parabola doesn't touch the x-axis at all. It doesn't cross the x-axis. It has nothing to do with the x-axis. It still has two solutions. They are just imaginary numbers. So say I gave you on your assignment a couple problems where I said match this equation to its graph using the discriminant. You'd plug in the numbers into the discriminant and say, oh look, the discriminant is 0. That means there's one real solution. That means this graph that has the vertex on the x-axis must be the matching graph. So this could help you on the EOC or the ACT test with matching up things fairly easily without doing a ton of work. So let's actually find the discriminant. Yesterday I mentioned that it's easier to use a quadratic equation where your a value is positive because you don't want to have to simplify a negative number on the bottom of the quadratic formula. When you're finding the discriminant, it really doesn't matter at all. So our a value here is -2, our b value is 3, and our c value is -7. Let's find the discriminant. b squared minus 4ac. Our b value is 3, so 3 squared, minus 4 times our a value, -2, times our c value, -7. Plug that into your calculator. So this is negative 47. When you plug this into your calculator, you can either do 3 squared minus 4 times negative 2 times negative 7, or you can do this first part in your head and punch in 9 minus 4 times negative 2 times negative 7. So our discriminant is negative 47. What does that mean about the number and type of solutions? 2 imaginary solutions. So for the number of solutions is either going to be 1 or 2, and the type of solutions are either going to be real or imaginary. Try number 8 on your own. A is 4, B is negative 4, C is 1. So B squared, you'd have negative 4 squared minus 4 times A, 4 times C, 1. If you're plugging in negative 4 squared into your calculator, please, please, please put parentheses around the negative. So negative 4 in parentheses squared minus 4 times 4 times 1. You should get 0. If you get negative 32, you plugged in negative 4 squared incorrectly. So be smarter than your calculator. If you're plugging in a negative number and squaring it, that negative number should be in parentheses. Otherwise, do that part in your head. Negative 4 squared is 16, so punch in 16 minus 4 times 4 times 1. You should get 0. What does a discriminant of 0 mean? 1 real solution. All right, let's turn the page and use some real-life quadratic formula problems. At the top of your notes, I'd like you to add something. We are going to write down the formula for an object dropped. The formula for an object dropped is h equals negative 16t squared plus h sub 0. An object thrown is h equals negative 16t squared plus v sub 0 times t plus h sub 0. If you're in physics classes, you probably call that v naught and h naught. It can also be said v sub 0, h sub 0. You can use those terms interchangeably. What I want you to notice is the difference between the object dropped formula and the object thrown formula. They are identical except for the middle term. In the object dropped formula, there's no v sub 0. There's no v naught. V naught stands for initial velocity. If you drop a ball, you are not imposing a velocity upon the ball. You're not throwing the ball downward. You are just letting go of it. So its initial velocity is 0. What is 0 times anything? 0. So in the object dropped formula, there is no middle term. There is no v naught times time. H stands for the height of the object in feet, and I'd like you to add in here that that's like the ending height. So if you drop an object, plane H is your ending height. So when the ball hits the ground, that would be a height of 0. That's your ending height. H naught, or h sub 0, is your initial, your starting height. So if you drop the ball from a height of 200 feet, 200 would be your h naught, your h sub 0. V naught, v sub 0 is the initial velocity in feet per second. That'd be if you were throwing or launching an object, or even if you were throwing an object downward, it's the velocity that you are imposing upon that object prior to releasing it. And t is the time that the object is in motion in seconds. So our first problem, if an object is dropped from 200 feet, how long will it take for it to reach the ground? So because we are dropping, we are not pushing it downward, we are not launching it downward, we are simply dropping it. We are going to use the dropped formula. If it's reaching the ground, that means our end height is 0. What is our starting height? 200. So plane H is 0. H naught, or H sub 0, is 200. So 0 equals negative 16t squared plus 200. We could use the quadratic formula for this, but we don't have to because there's only t squared. It'd probably be easier to just use square roots. So I'm going to add 16t squared to both sides. So I've got 16t squared equals 200. I want to get t squared by itself, so I'm going to divide both sides by 16. And even though this is a decimal, I'm going to go ahead and do the decimal. This is a real-life problem, so I'm actually going to get a decimal. So t squared equals 12.5. How do we undo the square? Square root. Normally we put a plus minus in front of the square root, but think about it. Can we have negative seconds? No. At least we haven't invented the time machine yet, so no. So square root of 12.5 on your calculator. The square root button is the second function of your square button. 3.54 seconds.